to computer. Again, welcome back to our lectures. In these lectures, we're going to discuss hypothesis testing with two samples. But this time, we are going to use small independent samples. Now, small independent samples means if the sample size is less than 30. So here we can perform a t-test for the difference between two means using small independent sample. Now, as we said, if samples of size or the sample of size is less than 30 are taken from normally distributed population, then a t-test may be used to test the difference between the population mean. It's mu1 and mu2. Now, there are three conditions so that are necessary to use a t-test for small independent sample. First, the samples must be randomly selected. Secondly, the samples must be independent. And thirdly, each population must have a normal distribution in order to use the t-test for small independent sample. Now, the standard test statistics is the formula given T equal to the difference of the mean sample minus the difference of the population mean divided by standard error. Now, the standard error and the degree of freedom of the sample distribution depends on whether, again, the variance for the populations are equal or not. Because we have two different ways of finding it. So the first, if the variances are equal, then we need to combine information from the two samples is combined to calculate the pool estimate of the standard deviation, which will give us this formula again. N1 is the sample size for the first sample, N2 sample size for the second sample, S1 and S2 are the S1 square and S2 square are the variances for the two samples. So here also we can find the standard error. The standard error will be the pool estimate of the standard deviation times square root of 1 over N1 plus 1 over N2. Again, N1 and N2 are the sample sizes. Then we can find the degree of freedom, N1 plus N2 minus 2. This is if the variances are equal. Now, if the variances are not equal, the degree of freedom will be the smaller value of N1 minus 1 or N2 minus 1, which means if the sample size is very small for N1, most likely the degree of freedom will be N1 minus 2. Other than that, if N2 is smaller than N1, then the degree of freedom will be N2 minus 1. So that's the variances are not equal. We've again find if the population variance are not equal, then the standard error is given. Yeah. Then, as we said, the degree of freedom will be the smaller of N1 minus 1 or N2 minus 1. So these are the steps. Are both sample size at least 30? If this is yes, then we can use the z-test. Use the z-test. If no, then we're going to check are both population normally distributed? If it's yes, we can still use the z-test. So here we say are both population, if it's yes, are both population standard deviation no? Then we can use the d-test. Now, if both population are not normally distributed, then we cannot use the z-test or the t-test. We cannot. But if that is the case, here we say if it's yes, use the z-test, even if the population is less than 30. I mean, the sample size is less than 30. Now, if it's no, now we're going to add the population variance equal, because remember, to use the t-test, we have option of if the variance are equal or not equal, we use different method. So we have to check here. Okay, if it's no, then this is how we find it. Use the t-test to find the standard error and degree of freedom also. Otherwise, if it's yes, then this is the way we also find the degree of freedom. And also this will be our test statistics with the estimated pool. Okay, so let's see in steps here. So in words, we say first thing we do in hypothesis test, as we said earlier, we always have to state the CRIM, which is the HO. Then we add state the NA. Always the HA will go against HO. Then next, we specify the level of significance, which most of the time is given to us, the alpha value. Also, we can identify the degree of freedom and sketch the sample distribution. Degree of freedom, all we need is the sample size. So we can either use N1 plus N2 minus 2 or the smaller of N1 minus 1 or N1 minus 2. This is if, again, the variances are not equal, of both two samples are not equal. Then we can determine the critical value using the table 5 in Appendix B of our course textbook. Then we can determine the rejection ranges by finding the standardized test statistics. Then we can make a decision to reject or fail to reject the null hypothesis. So to determine rejection region, we need a critical value. To make our final decision whether to reject or fail to reject the null hypothesis, we have to find a standardized test to see if it will fall inside rejection area or not. So let's see an example. Here we say a braking distance of 8 Volkswagen GTIs and also 10 Ford Focuses were tested when traveled at set 60 miles per hour on the dry pavement. The results are shown below. Can you conclude that there's a difference in the mean braking distances of the two types of cars? This time we are going to use alpha to be 0.01. 0.0. Assuming the population are normally distributed and also the population variances are not equal. Very important. Now, when we look at the sample size, we can see that it's less than 30, 18 total together. So here we can use the t-test. So we state, based on the question, we state our HO and HA. Then we have alpha to be 0.01. So degree of freedom, we have 2, 10 minus 1 or 8 minus 1. So the smaller will be 8 minus 1, 7. So if we know the degree of freedom, we know the alpha, we can determine the rejection region, which gives us somewhere between negative 3.499 to 3.499. Then next, we can find the test statistics. Again, these values are given to us. Let's go back to our question. We can see the sample mean 134 for GTI, Focus 143. So those are the two samples means. So we plug in the values and we get the value to be negative 3.496. So negative 3.496 fell in not rejection area, fell in the brown area. So here we are going to fail to reject HO. Anytime it fell in the blue area, that's when we are going to reject HO. So this means at 1% level of significance, there is not enough evidence to conclude that the mean braking distance of the cars are different, because HO means they are the same. Now, let's try another question here. Here we say a manufacturer claims that the calling range in feet of his 2.4 gigahertz cordless telephone is greater than that of his leading competitor. You perform a study using 14 randomly selected phones from the manufacturer and 16 randomly selected similar phones from its competitors. The results are shown below. At alpha 0.05, can you support the manufacturer claim? Assuming the population are normally distributed and population variances, this time the population variances are equal. Again, according to the manufacturer claim, the calling range in feet of his 2.4 gigahertz cordless telephone is greater than of his leading competitor. So the manufacturer, we have the mean, we have the standard deviation, we have the sample size. Competition, we have their mean, we have the standard deviation, and so we have the sample size. So we can start with our HO and HA. So mu1 less than or equal to mu2, mu1 greater than mu2. Alpha is given to us to be 0.05. Remember the question here said the variances are equal. So degree of freedom will be N1 plus N2 minus 2, which gives us 28. We know the alpha, we know the degree of freedom, we know the sample everything, so we can be able to come up with the rejection. This time it's not equal or equal, so it's only one way. So based on our table, we get the value to be 1.701. Now we can calculate our test statistics using the formula given to us. We know N1, we know N2, we know S1, S2. So we plug in all the values. And when we do our calculation, we get 13.8018. So let's see the region where it falls. So after that, so this just again, we get 1.811 to find the t-value. So let's say the region where it fails. Okay, so here we are going to again reject the, so we're going to reject the HO, fall in the blue area. So at 5% level of significance, there is enough evidence to support the manufacturer claim that its phone has a greater calling range than its competitors. So that will be the conclusion of this lecture. So here we perform a t-test for the difference between two means using, again, small independent samples. One thing we should remember is that, again, depends on the variance, the degree of freedom, formulas always change with the t-test also. So either the variance are equal or they are not equal. And again, see you in the next lectures. Thank you.